In this video, we're going to do W substitutions, which is a U substitution twice. Now, the key in this is to take the denominator and we need to complete the square. So if we complete the square, we get x squared minus 4x plus blank plus 8 plus blank. Half of negative 4, the middle term, is negative 2, squared is 4. So that we don't undo the problem, we're going to subtract 4 on the other side. So now this factors as x minus 2 squared plus 4. And that's a key step from Algebra 2. So from here, we would go integral 1 over x minus 2 squared plus 4 dx. You need to recognize that that is very close to inverse tangent. We do have an inside function, so let's take a look at the inside function. U is x minus 2. du would be 1 dx. We have the 1 dx, so we can now convert this integral into 1 over u squared plus 4 du. Now you'll notice it's getting closer and closer to inverse tangent. But we have this 4 in the way. So in order to get rid of the 4, we're going to divide by 4 everywhere. So now we've got the integral of, and I'm going to push the 1/4 out. I might want it back in, but I'm going to push it out for the moment. I've got 1/4 u squared plus 1 du. Well, now we've already used u as a substitution, but I still have an inside function of 1/2 u. So we're going to use w as our substitution now. So if w is 1/2 u, dw is 1/2 du. I don't have a 1/2, so I'm going to put a 1/2. I'm going to multiply by 2 out in front. So now I have a 1/2 integral 1 over w squared plus 1 dw, and this is inverse tangent. So now I can go ahead and go 1/2 inverse tangent of w plus c, but it's not really w, it's really 1/2 inverse tangent, and w was 1/2 u plus c, but it's not really u, it's really 1/2 inverse tangent of 1/2 of what u was, which was x minus 2 plus c as our final answer. So again, the key is to complete the square in the denominator to set this up. Let's do a second example. We're going to start by completing the square in the denominator. So x squared minus 2x plus blank plus 17 plus blank. Half of the middle number is negative 1. Squared is 1, which means we're going to put a negative 1 on that side so as not to change the problem. The trinomial factors as x minus 1 squared plus, combined like terms, we get a 16. So our new denominator, integral of dx, x minus 1 squared plus 16, begins to look like inverse tangent. So inside function u is x minus 1, du is dx, and we have that. So now we can replace and say 1 over u squared plus 16 du. Our 16 is in the way, so let's divide by 16 everywhere. I'm going to go ahead and pull that 1/16 out. I may want it later, I may not. So I've got 1/16, 1 over 1/16 u squared plus 1 du. Once again, we've already used u, so this time we're going to use w. We're looking for the inside function, which is 1/4 u. So if w is 1/4 u, dw is 1/4 du. So if I want to put a 1/4 here, I need to multiply out front by 4. I now have 1/4 integral of 1 over w squared plus 1 dw. Again, that would be 1/4 inverse tangent of w plus c, but it's not w, it's 1/4 inverse tangent of whatever w is. In this case, it was 1/4 u plus c, but it's not really u, it's really 1/4 inverse tangent of 1/4 of whatever u was. U was x minus 1, so we have x minus 1 plus c. Let's try one more quick example. So again, we're going to complete the square on the bottom. X squared plus 6x plus blank plus 34 plus blank. Half of 6 is 3, squared is 9, so negative 9. Factor is x plus 3 squared plus 25. Replace the denominator, so we have 1 over x plus 3 squared plus 25.
Bradford, please report to the front office. Bradford, please report to the front office. Thank you.
U is the inside function of x plus 3. du is dx. So now we have the integral of 1 over u squared plus 25 du. The 25 is in our way, so let's divide the 25 everywhere. We could go ahead and push that 1/25 out if we want. So a 1/25 integral 1 over 1/25 u squared plus 1 du. Since we already used u, we're using w. What's inside is the 1/5 u. So let's take a 1/5 u. dw is 1/5 du. Put a 1/5, got to multiply by 5. So now we have 1/5 on the outside, 1 over w squared plus 1 dw. That's 1/5 inverse tangent of w plus c, but it's not really w, it's really 1/5 inverse tangent of what w was. In this case, that was 1/5 u plus c, but it's not really u, it's really 1/5 inverse tangent of 1/5 of whatever u was, and u was x plus 3 plus c.